Let me define what is the binomial distribution. For the binomial distribution, we need the Bernoulli trials. It is one of the probability model in statistics, the Bernoulli trials. Simply, I can give you an example for the Bernoulli trials. Toss a coin. Please remember, toss a coin for the Bernoulli trials. When I toss a coin, how many outcomes? Only 2 outcomes. You know, when I toss a coin, we are going to have only 2 outcomes, head or tail. It is a Bernoulli trial. When I select one of you, how many outcomes? Male or female. 2 outcomes. Another example for the Bernoulli trials. When I toss coins, the second toss, it depends on the first one. For example, I got head for the first one. Do you expect the second outcome will be head again? How about the third one? Next one. They do not depend on each other. The trials are independent. That is the second condition for the Bernoulli trials. Yeah. So please remember an experiment, toss a coin. Exactly, it is the Bernoulli trials. And the last one, every single time we have the same probability to get head, 50%. Independently, the second toss, we can expect the head with the 50%. The next tossing, 50% head. The next one, 50%, 50%, 50%. Independently, every single trial, we can expect the same probability. So when we satisfy the 3 conditions, only 2 outcomes, independence, same probabilities, then we can say it is a Bernoulli trials. Please remind the previous example. We selected 3 persons. Success, failures, to be alive or died, independent. And each person has the same probability, 80%, to be alive. Yeah? Exactly, it was the Bernoulli trials. But we selected 3 times. So I gave you an example, toss 1 coin. The experiment, toss 1 coin, that is the Bernoulli trials. But when I toss a coin many times, for example, 10 times, now it is the the binomial distribution. So repeated Bernoulli trials, then the random variable is the number of successes. That is the binomial distribution. So we assumed we have some conditions and independent trials. As more in details, I can say we do independent and Bernoulli trials. Next, it has only 2 outcomes. You know, actually the binomial distribution from the Bernoulli trials, again, only 2 outcomes with the same probability of success, P. So please remember the 3 conditions. N, independent trials, only 2 outcomes with the same probability. Then we can use the binomial distribution. You know, I told you we have many kinds of given common probabilities, probability models, random variables. The first one was the binomial distribution, the binomial probability model. Here's the way we take the probabilities. You know, before the previous example, we made the probability trees. Success, success, and success. Probability was 0.8 times, 0.8 times, 0.8. And the others, success, success, failures, success, failure, success, one by one, we made probability trees, and we plug the probabilities, apply the multiplication rule, take the probabilities, and then make the table for each value of the random variable, right? Yeah? But here's a formula. Here's a formula to take the probability. It has 3 terms. First, second, and third. Let me make it bigger. Take the probability for any value x. We just take the 3 terms, the first one, second one, and the third one. Okay? So separately, we take the 3 terms and take the multiplication. It is a formula. The very first one is this. It has a name, binomial coefficients. Yep, like this one. Look at this. Have you ever seen this notation before? Like this? What is this? Have you ever heard of factorial? No? You know, most of your calculator has this one. Okay? Let me show you. If you have a TI-84, if you have a calculator, TI-84, then you have a key, the math, is up here, the math key. When you click the math key, please click the math key if you have a TI-84. I will show you, it's another calculator, but now if you have a TI-84, please click the math key. And there are 4 or 5 columns. Can you see them? And please go to the PRB. Please go to the column titled the PRB. How do you think? What does it stand for PRB? Probability. Yes. So please go to the probability, PRB. Then number 4. Can you see the notation? Factorial? Yeah, absolutely. We can use the function factorial. If you have n spire cx is much better than TI-84. The better means it's more expensive. Then you can go to the menu. When you have an n spire, go to the menu. Number 5, there is the probability. Then you can see the factorial key. And any other?
Which one is it?
That is.
Oh, okay.
And okay, even you have a cheaper one, TI-13 something, then you have the key PRB directly. You don't have the math key, but you can have the key with the title PRB. Then you can see the factorial functions. Okay, but it's honestly we don't need the factorial. We don't need it. Yeah, ignore it. Directly, we can take the first term. Please go to the menu. If you have a TI-84 or Nspire, please go to the menu. Please click the math key and go to the PRB, probability. Number 4 was the factorial, but we are not going to use the factorial. But please look at the number 3. C, can you see the function of C? NCR, C. The C stands for a combination. If you have an Nspire calculator, you can go to the menu, number 5, probability, then you can see the function of the combination. So we are going to take the combination. It's not a factorial. I will show you the next example. So please remember, we have 3 terms. The first one is actually, it is the number of combinations. And the second term, P with the power of X. What was the X? X was the number of successes, the random variable. And the last one, it is 1 minus the probability, P. The probability was the probability of success. And the power is N minus X. Just a second. What was the N? N was the number of independent trials. X was the random variable, the number of successes. So please remember the formula. And please understand who are there. Who are they? N, again, the number of independent trials. X was the random variable, which was defined as the number of successes. P was a probability of success. So we need the 3 numbers, the 3 values. N, X, and P.